What's up, Webster Groves? We are back with video notes, wave energy, goal 1. In this goal, you need to be able to describe transverse and longitudinal wave movement. You need to be able to describe the difference between mechanical and electromagnetic wave types and label the parts of the wave. Vocabulary words here we have transverse, longitudinal, mechanical, electromagnetic, and wave. Okay? You're also going to need to know these parts. If you're exceeding the goal, you understand the relationship between wavelength and frequency. So we have a lot of stuff kind of packed into this one goal. But if you have a basic understanding of wave properties, then a lot of the other stuff in this unit is going to come pretty easy. Alright, so here we go. What is a wave? A wave is a disturbance that transfers energy from one place to another. If you have ever been to the ocean, you've probably seen waves like this. And they carry a lot of energy. They can be pretty powerful. I remember one time when I first started getting into sea kayaking in high school, I had a wave that was smaller than this, but still it was enough to tip over my kayak and send me swimming. So waves can carry a lot of energy. Doesn't matter if it's a water wave, a light wave, or a sound wave, but waves are a disturbance that transfers energy from one place to another. Parts of a wave. Okay, up here we have the crest, the top part of the wave. Down here we have the trough. Think of like a feeding trough or a horse trough. Think of it's kind of shaped like that, the trough down here. Wavelength, this is the distance between two troughs or the distance between two crests. So from trough to trough or crest to crest, that is a wavelength. Amplitude is the distance between the resting point and a crest, or it can be the resting point in a trough. So that is amplitude. Okay? So this is a measurement, and this is a measurement. This is a part, and this is a part. Okay? Another part is going to be the resting point. Okay? So resting point. This is the point where this is the level that things are going to be at if there is no disturbance, if there's no energy being transferred, the resting point. Other words we need to know. Frequency is the number of waves in 1 second. The unit, which you need to know, is hertz, spelled the same way as the car company, or car rental company, hertz. A medium. Medium is the matter that a wave travels through. Okay, so it can be air, it can be water, it can be a solid, it can be whatever. Whatever it is traveling through, that is the medium. And then wave speed. Think of speed, we often think of distance divided by time. It's the same thing here, it's just the distance is wavelength over time. Okay? So those are our parts of a wave. Finding wave frequency. Okay? So first we need a resting point. Okay? And then let's put in our wave here. Whoa, catch the wave. We'll put a little surfer dude here. Whoa, man. Like hang 10 on my wave, dude. Alright, so we got our wave, and frequency is the number of waves per second. So we have to count waves here. To count waves, you want to count the number of full crests or the number of full troughs. Okay, so we'll count our number of full troughs. We have 1, 2, or if we wanted to count crests, we would count 1, 2. Either way, okay, we have 2 waves. Let's say that these waves are happening in 4 seconds. Pretty quick. Okay? So waves per second. If 2 waves are happening in 4 seconds, how many waves per second? Okay? We do 2 divided by 4, so we get 0.5. So our frequency is 0.5 waves per second. So our unit is hertz, abbreviated Hz. Okay? So that is our frequency. And that's a pretty low frequency. Okay, but still, that's our frequency. Finding wave speed. Again, we'll draw a wave here. Fancy wave. But this time, Surfer Dude is going swimming because he fell off his board. Bummer. Alright, so we've got our wave, and this time we're finding speed, which is wavelength divided by time. So to find wavelength, we need to measure the distance from trough to trough. And let's say that this distance happens to be 8 meters, okay, for an ocean wave. And our time for these waves to happen is 12 seconds. Okay, so 12 seconds. So we take our time, take our distance divided by time, and we simplify that. We're going to get 2/3, which in a decimal is 0.6, repeating, and we will round it, and we will say 0.67. Okay, so 0.67 meters per second. Okay, so that is our speed of our wave. Okay, so that's how we find speed for waves. Here we go. Wave movement. We have a transverse wave movement, and in a transverse wave, the particles in the wave move up and down in a direction perpendicular to the direction the wave is traveling in. Okay, so wave motion is back and forth, particle motion is up and down. To take a look at this, we have a video. Okay, so you can see particles moving up and down, waves moving back and forth. This is a transverse wave movement. This is not a type of wave, this is a kind of wave movement, a transverse wave movement. The other kind of wave movement is a longitudinal wave. And in this wave movement, we have the particles in the wave moving back and forth in the same direction as the wave. So wave motion is going back and forth, and so is the wave. Okay, so think of a slinky. This would be how sound waves move. One particle hits the next particle, and they compress and relax. So that's a longitudinal wave movement. You have the motion of the wave and the particles moving in the same direction. So if we compare these two, if we compare these two side by side, it's going to look like this. Alright, we have two different kinds of wave movement. We can see our transverse wave, particles are moving up and down, going across. Longitudinal wave, particles are moving back and forth, and the wave is moving back and forth. Okay? So that is the different types of wave movement. The different kinds of waves. We have mechanical waves. These are waves that have to have a medium. They have to have something to go through. They have to have matter to go through. No matter, no wave, because it don't matter. Okay, bad science joke. But mechanical waves need a medium to travel through. Electromagnetic waves do not need a medium to travel through. An example would be light waves. This is why the sun's light can get to Earth, because it doesn't need matter to travel through. If light was a mechanical wave, we would be a frozen rock. We would not exist. So sound is a mechanical wave, has to have matter to travel through. So that means if you had something explode in space, even if you were right next to it, you wouldn't hear it because there's no matter in space, there's no air. So you have to have matter to travel through for a sound wave. No matter, no sound. Okay, so those are the two different kinds of wave movements. You've seen that, and that's all. That's it. Okay, thank you for watching, and if you have questions, please bring them to class.